Okay, hi. For science today, again, this is optional, but two things. Number one, we are going to go over the show what you know from like last week. I'm so sorry I have not posted this yet. So that's the first thing that we're going to do. And the second thing we're going to do is talk about the building of the airplanes, which is going to be happening next week. I always love doing this the last week of school. It's so much fun. And I think you guys are still going to have fun doing it because essentially you're just like racing against yourself and you're trying to be the best version of yourself as a plane engineer as possible. And then on the last day of school on Tuesday, that's gonna be a moment for you guys to show off the planes that you have built and maybe like the design reconstructions that you have made. Okay, so here we go. We are going to go over the show what you know from last week. Okay, so alrighty. So hopefully you guys have the answer key with you, or not the answer key. Sorry, like the guide which I put on your own individual pages in Edmodo. Okay. So I put a K by the questions that are knowledge based and then an A beside the questions that are application based. And then that's going to give you an indication of like which ones are which. So question number one, I didn't label them in here, but question number one is this one. Which of the following examples best illustrates the compression of air? So inflation of a tire because you have compressed air inside of a tire, which we talked about. The rest of the examples don't make sense. Okay, next one. At a birthday party, for his younger sister, Quinn performed a magic trick. He asked one of the guests. Okay, so this is like the paper diver one, right? So he put the crumbled paper in here, turned it upside down. Okay, what property is, okay, so the kids cheered and Quinn smiled, knowing that the reason the paper was not wet was because air takes up space and could not escape from the jar, and therefore no room was left for the water to get in. So the answer for number two, which is a knowledge-based question, is C. Number three, Maddie and Zaha conduct an experiment to demonstrate the properties of air. Maddie covers the opening at the bottom of one end of an air gun or a syringe kind of thing. Zaha pushes on the plunger. Here. They observe what is happening. Okay, so which of the following statements best explains why the plunger can move the air in the barrel? Okay, so this is the barrel. Why is it possible for this plunger to move? What is happening in here? If we were to visualize the little molecules of air that are in the plunger, they're being stopped, right? They cannot get out. So we know that one of the properties of air is the molecules are free moving, they have spaces between them, but we can push them closer together. So what's happening is the air inside the gun is being compressed. That is the answer. This is a knowledge-based question again. So basically, yeah, the molecules are being compressed. There would be higher air pressure inside because it would want to equalize back out. So less air pressure outside the gun. Yeah, that would also be correct, but that doesn't answer the question. The question is asking, why can the plunger move within the barrel? It has nothing to do with air pressure outside. The air pressure outside the plunger isn't pushing the plunger in. It's the fact that air can be compressed. That's why this is the correct answer. Air pressure is greater outside the gun. That's fully incorrect. And then the air inside the gun is being pulled down by gravity. Not in this example, because you could have it flipped upside down. It doesn't matter. Gravity doesn't play an impact in this experiment. Okay, number 4. Bernoulli's principle states that as the speed of a fluid increases faster, the pressure exerted will decrease. Okay, fast moving air, low air pressure, still air has higher air pressure. Okay, so the answer should be B for that one. Number 5, Rajvi places a strip of paper between the pages of her line of stories book so that half the paper is flying out. We did this experiment together as a class. Okay, so as Rajvi blows over the top of the piece of paper, what's most likely to happen? The paper will lift up. That's right, because there is low pressure above the paper. Is that right? Air will lift up because the air of low pressure above the paper. Oh yeah, of course. Yes, of course it's low pressure above the paper. Of course. Sorry. It's fast moving air, right? She's blowing the air quickly over top of the piece of paper, which is creating the low pressure. The high pressure underneath is creating the lift to happen. So that is the correct answer. Yeah. Perfect. Next one, Ibrahim. This is exactly like the Bernoulli Bridge experiment. So hopefully this one was kind of a bit of a giveaway. Ibrahim asked this is number 5, I think. Yeah. No, sorry, that's number 6. Okay, so 1, 2, 3, 4. Rajabi was 5. Ibrahim is 6. Okay, so what's going to happen is we blow underneath the paper. So it's going to collapse to the table because the moving air lowers the air pressure under the piece of paper. Exactly. Fast moving air, low air pressure, still moving air, high air pressure. Okay, 7. Which of the following positions would be most efficient for reducing drag? Oh, I think I made one of these guys, Mr. Scott, cycling along. What would be the best position for him to go ultra fast? C. Okay, knowledge-based, more aerodynamic. What would be the worst position? I think this one looks like he's further up. The A right here is like a little bit more bent over. Yeah. So C is the fastest, most aerodynamic position. Number 8. This was a little bit of a tricky question. Okay, and I actually, if you would have seen your mark right away, this one was edited afterwards. Because I think the answer key had the wrong thing initially. Okay, so large plastic bag, basically we're creating a hot air balloon. This is kind of going back to the concepts we learned about the speed of air molecules to do with the temperature. So plastic bag and air hair dryer used as a model of a hot air balloon. When the hair dryer is turned on, it blows hot air into the bag. Yep. The moment the hair dryer is turned off, the plastic bag is released and floats upward. Cool. We should know this from grade 5, right? And we talked about this as well. Fast moving air, high energy is going to move up. Slow molecules that are close together are more dense and they come closer down to the ground. So the reason that the plastic bag floats upwards is because the air inside the bag is less dense than the air outside the bag. Exactly. Yeah. Less dense, so it's gonna float up. It's less dense, it's lighter, it's gonna lift. If it's more dense, it's heavier, it's stuck together. Like you have like a really dense like cake, right? It's heavier than like a light and puffy cake, and then it's gonna sink down. It's gonna be heavier. So that is true. Yeah, so B is incorrect. The molecules inside the bag are moving more slowly than molecules outside the bag. That is incorrect. If it was moving quicker, then it would be correct. Molecules inside the bag are closer together than molecules outside the bag. That again is incorrect. They are actually further apart because they have more energy. So A is the only one that actually is correct. Okay, I think this is number 8. A structural engineer designing a bridge for over the Bow River in Calgary. Part of the design construction is the shape of the bridge support that extend into the fast flowing water. Which of the following designs would offer the least resistance to the water? So basically, AKA, what's the most aerodynamic? B, right? Huge block surface. Block surface, good, but it's going to create these eddies, right? It's going to create this turbulence behind. So B is the most aerodynamic position. But is there even a better position? This one. If you're in charge of redesigning the bridge support, what would you do to further increase the aerodynamic properties of the shape? Create a teardrop shape. That's the best one. Yep, we learned that in one of our labs. All right, now this next part is kind of flight. So parachutes cause objects to fall to the ground more slowly because, yes, they increase air resistance. They're increasing drag. So air resistance and drag are synonyms. So that's true. They don't have anything to do with the force of gravity. The force of gravity is a constant that never changes on the planet of Earth. So those parachute does not impact gravity. It does increase the drag. Okay, next one. Falcons have physical characteristics such as a pointed beak and long tapered wings. These characteristics help falcons to fly quickly and descend rapidly. Okay, so cool facts. The physical characteristics described above mainly allow the falcon to, Yes, increased lift and decreased drag, right? Because they're streamlined in shape and they have long wings. So they would create a lot of lift and then they would be sleek. So they would be decreasing drag, which makes them fast, right? Like if you look at all these things, like even if they haven't even said anything up here, the physical characteristics that allow the Falcon to fly quick, would it increase lift and drag? Does that make any sense? No. Decrease both lift and drag? That also doesn't make any sense. Increase lift? Yep. Decrease drag? Yep. Decrease lift? Well, no, that's not going to help it fly. And then increase drag, that's going to be the worst thing. It's like you're making a bus here. Okay. All right. So that's that one. Next one. While observing penguins at the zoo, Fast explained to his younger sister that the enclosure does not have a roof because penguins cannot fly. True fact. The reason that penguins cannot fly, even if you don't know much about penguins, we can figure it out based upon the principles of flight. The answer is the force of gravity is greater than the lift force for which the wings are able to generate or produce. True. They just can't simply take off. Drag forces created by the body prevent lift. Not really drag forces. They're actually hyper aerodynamic little things. They can swim like crazy in the water. Thrust forces cannot be generated by their leg muscles. No, they can push off, they're fine, but that doesn't create enough thrust. So that's actually not the worst answer, but maybe there's a better one, right? The force of gravity is less than the lift force than the wings can generate. That doesn't make any sense. If the force of gravity is less than the lift force, then they would be able to take off. That one doesn't make any sense. So the force of gravity is greater than the lift force. Yeah, right? The force of gravity is beating the lift force. Then they can't generate. All right, next one. Vultures' smooth feathers are well adapted for flight because this adaptation reduces. If it's smooth, it's going to reduce drag, decreasing block surfaces. Okay, last couple were related to an experiment. So this is going back to like the first things we learned at the beginning of the year and then kind of like repeat a bit. Daniel conducts a test with a model airplane powered by an elastic band propeller. He constructs a model plane and launches it 3 times. Before each launch, he twists the elastic band a number of times. Okay. The results are shown below in this table and graph. Okay, cool. So launch 1, he twisted it 5 times. 2, he twisted it 10 times. So more it's going to be tighter, right? 3 times, really, really, really tight. So more of that potential energy. Remember that from earlier? Potential stored energy compared to kinetic, which is moving energy. That's not grade 6, but it's cool to know. Based on the information, the table, and the graph, which of the following questions would Daniel be most likely to try to test? Okay, so the answer is, how does the number of twists of an elastic band affect the distance the model airplane travels? Perfect, right? More times you tighten this up, does it impact the distance, which is what we're measuring? So that's a great one. Okay, doesn't really affect drag. Does the elastic band affect the speed? Well, that would be the best distractor answer. But are we measuring speed? No, we're measuring the distance it traveled. Speed is measured with like meters per second, kilometers per hour. So what we're measuring is the distance traveled. Tricky fooler question. What is the manipulated variable? The manipulated variable is the thing that Daniel is manipulating or changing. So it's the number of times the elastic band is twisted. Same airplane, there's no drag that's different, and the distance traveled, that does change, but that is the responding variable. All right, there you go. Okay, that's our review.